Alright, in today's video we're going to be looking at the discriminant. And when we talk about the discriminant, what I mean is this little part of the quadratic formula. So this may look familiar to you, and b squared minus 4ac. And these components can be found in the quadratic formula, right? b squared and the minus 4ac that normally goes underneath the radical. So what we're going to do now is we're going to go ahead and use this part of the quadratic formula that we call the discriminant to be able to determine situations for quadratics. So what I'm going to do is I'm going to go ahead and rewrite this b squared minus 4ac. And the place where we get these values is the same as if we were trying to do the quadratic formula. Just remember that our a value, and I'm going to write it right on top, the number that's in front of x squared. Our b value is the number that's in front of x, and our c value is the constant, right? The value that does not have a variable. And so we're going to go ahead and substitute our a value, our b value, and our c value. Now for a, some of you may realize that there's no number in front of x, but remember there is always a number there. When you don't see a number in front of it, it just means it's that invisible 1. So in this case, a is going to be 1. So I'm going to go ahead and perform the substitution right quick. Now in place of b, I'm going to put a set of parentheses. And then I'm going to go ahead and put square minus 4. And in place of a, I'm going to put a set of parentheses. And in place of c, I'm going to put a set of parentheses. So the c value is going here. My a value is going here. And the b value is going right there. So for b, we have a positive 2. I'm going to put in place. For a, we have a 1. That's the 1 that would be in front of that x. And for c, that's our constant value, which is negative 35. We're going to put that value in. So I have b squared minus 4 times the value of a times the value of c. And I'm going to put it in my calculator just as we wrote it right here. So you're going to see that it matches. So I'm going to move this over just a little bit, open up my calculator, and I'm going to go ahead and put a parenthesis, put my value of 2 for b in, and then I'm going to square it, minus 4 times my a value of 1 in parentheses, and my c value of negative 35. So notice it looks just as I wrote it right here. I put it in my calculator, I'm going to hit enter. And in this case, it tells me that it's 144. So when calculated, all of this together gives me 144. That's my discriminant. So in this case, the discriminant is 144. And 144 is greater than 0. Therefore, this particular quadratic has 2 real solutions. What that means is that if we graph it, we're going to see that it crossed the x-axis in 2 places. So let's graph it just so you can see what I mean visually. So I'm going to go ahead and hit y equals. I'm going to type in this quadratic. I have x squared and then plus 2x minus 35. I'll hit graph, and you can clearly see that it crosses in 2 places. So it looks like it crosses at negative 7 and it crosses at positive 5. So those are our zeros. I'm going to go ahead and just draw a sketch. So this is what our graph looks like when our discriminant shows that we have 2 real solutions. It means that it crosses in 2 places on the number line. Now, let's go and take a look at the next one. Now, in example number 2, we're going to be looking at what it looks like when you have a double root, which means that discriminant should be equal to 0. So I'm going to go ahead and I'm going to write the discriminant right quick. So we end up having b squared minus 4 times a times c. So I'm going to put parentheses for b minus 4, and I'll put parentheses for my a value and parentheses for my c value. Now I'm just going to go ahead, I'm going to label these right quick. This is my a value is going to be 9, my b value is going to be negative 6, and my c value is going to be positive 1. So if I put those, notice we put b first, so we get our negative 6 and place it in place of the b in parentheses. And then I'm going to get my a value, which is 9, and put it in place of A. And my C value is 1. I'm going to go ahead and put it in place of C. And now I'm going to type this in the calculator real quick, and we'll see what we get. Alright, so I'm going to put parenthesis, and then I'm going to have -6, close parenthesis, squared, minus 4 times 9 times 1. And I'm going to hit enter, and notice it gives me 0. So this equals, all equals 0. Now notice in this case, right, it says when the discriminant is equal to 0. So this is our discriminant. And it's 0, and it's equal to 0. So we're going to go ahead and say that we have a double root. And now if I were to graph this to show you what it looks like when you have a double root, to give you a graphic image, I'm going to go back to my calculator, and I'm going to type it in. So I have 9x squared minus 6x plus 1. And notice you can see it come down and contact this one point and then go back up. If I were to zoom in, it would be more clear. And you can see how it only touches the x-axis at one place. So in this case, it looks like this. And so I'm going to write this is a double root. And for our last example, we have this situation right here. So let's go ahead and get our discriminant. I'm going to write b squared minus 4 times a times c. I'll leave a set of parentheses to put in my b value and square it. Minus 4, parentheses for my a value, and parentheses for my c value. Now I'm going to go ahead and label this, right? This is my a value, my b value, and my c value. So my a value is going to be 1, b is going to be -4, and c, the constant, is going to be 5. So we're going to write those inside of our discriminant right quick. So we start with our b value, so I have -4 for b. My a value goes next, it's 1, so I'll put a 1 there. And then my c value is +5, so I will put a 5 in there. And now we're just going to put that in the calculator and see what it gives us. So I'm going to put parenthesis, -4, close parenthesis, squared, minus 4ac. A value is 1, c value is 5, and hit enter. And notice it gives me a negative value, -4. So our discriminant is -4. And -4 is less than 0. So because of that, we know that this is going to have no real solutions, or what we say is no real roots. Now, we also call this an imaginary solution, right? It's going to be made up of an imaginary number. In other words, that I, that represents -1 inside of a radical. So if I were to give the solution for this, for example, it would look like this. X equals 2 minus I, where x is equal to 2 plus I. Those would be our solutions. And we have this I because we had to pull that -1 out of the radical in order to solve for its solution. So that means that when we draw this image on this graph, it's not going to touch the x-axis at all because there's no real solution. So let me go ahead and graph it just to show you what it would look like so you can get an idea. So I'm going to go ahead and go here. I'm going to clear my old graph out, and we'll put in there x squared minus 4x plus 5. And graph it. And we may have to zoom out for this one. You can see right there, it never touches the x-axis. So if I zoom out real quick, let me go to standard. You can see while it comes close to the x-axis, it does not touch. So if I were to draw an image of this to see what it looks like, it looks quite like this. There are no real solutions because it doesn't cross. Now also keep in mind that many times when we have a solution like this, where we have an imaginary number, we also like to call it a complex solution. And that's everything you need to know about using the discriminant to determine what type of solution you have.